All right, good morning, everybody. Today's video here is about temperature conversions. What I'm going to do here, we're going to show you how to convert from Fahrenheit to Celsius, Celsius to Fahrenheit, and we're also going to introduce, perhaps some of you know about the Kelvin temperature scale, maybe some of you don't, so I'm going to go ahead and talk about that as well. Okay, so first of all, converting from Fahrenheit to Celsius and Celsius to Fahrenheit. The formulas are a little bit be a little bit confusing, but it's once you get some practice with it, hopefully it will, it won't be so bad for you. So the formula for calculating going from Fahrenheit to Celsius. See, in the United States, as I'm sure you know, we express our temperatures in terms of Fahrenheit. Well, you drive about 3.5 hours, not even 3 hours. You get up into northwest Ohio, going up towards Toledo, Bowling Green, Toledo area. You can pick up Canadian radio stations, and the Canadian radio stations, they report the temperatures in Celsius. So the digital output in your car might say it's 75 degrees. Well, 75 degrees that's Fahrenheit, of course, and it might indicate that, but in Canada they would report 75 degrees as well, let's just figure that out here real quick. 75 minus 32 equals that times 1.55. They would say it's 24 degrees, but they'd say Celsius, because let's face it, 24 degrees Celsius and 24 degrees Fahrenheit, not the same at all. We know what 24 degrees Fahrenheit feels like. But we know what 75 degrees Fahrenheit feels like as well. So here in the United States, Fahrenheit is used, but most of the other world, including in science, Celsius and Kelvin are used, which we'll talk about Kelvin here in a little bit. So here's the formula to convert from Fahrenheit to Celsius. Degrees Celsius equals 5/9, and then in parentheses, notice the parentheses, F minus 32. So whatever the Fahrenheit temperature is, plug that in here, do the parentheses first, and then multiply by 5/9. Now, you could use the decimal equivalent of 5/9, which is 0.55. All right, it's up to you. If you're more of a fractions person, you like messing with fractions, that's fine. Use the 5/9. If you'd rather use the 0.55 because that's easier for you, I get that too. So what I did here is I showed you how much of a difference there is when you use, here I use the fraction, so I just, 57 minus 32 is 25, so I did the parentheses first. You have to think PEMDAS in the, along here. Parentheses, exponents, there's no exponents, multiplication, division, addition, subtraction. So 5/9 times 25 is 13.89. If I use the decimal, 0.55 times 25 is 13.75. Doesn't really matter which one you use. In all honesty, have you ever seen or heard a weather report where they say the current temperature is 65.25 degrees Fahrenheit? No, they're not going to say that. They're going to round temperatures to the nearest degrees. So that's what I did here. So 13.89 and 13.75 both round up to 14 degrees. As far as I'm concerned, you don't have to round up if you don't want to. I'm just letting you know that standard convention is that you typically report temperatures in terms of just whole numbers, no fractions or decimals involved. So again, slight difference here, but that's okay. If you're comfortable with fractions, use those. If not, you want to use decimals, use those. It's fine. But the important thing to remember here with this formula is to do the parentheses first, then multiply by what's outside the parentheses. Now, that being said, I want to show you converting from Celsius to Fahrenheit. Do you notice any punctuation that's missing in this formula? There's no parentheses. So do not include parentheses when you're going from Celsius to Fahrenheit. There's no parentheses in the formula, so don't put them in there. So all you do, if you're converting from Celsius to Fahrenheit, you're going to know the Celsius temperature. Here's an example, 115 degrees Celsius. Now, some of you if not all of you, may know that, oh yeah, water boils at 100 degrees Celsius. This is hotter than that, so we're talking about, water vapor at this point, all right? Because this is warmer than that. So, at any rate, 115. Plug that in here. Now I use parentheses here, and I see that, and I'm thinking, I really shouldn't do that. I suggest put in a multiplication symbol. All right, so that way there's no confusion, because I don't want to get you confused. That's like the last thing I would want to do. So 9/5 times 115, get an answer, plus 32. Get a product first, 9/5 or 1.8. It works out the same either way. Okay, so 9/5 times 115, you get an answer. Add the 32 to it. There's your temperature. So 115 degrees Celsius is equivalent to 239 degrees Fahrenheit. You may know that water boils at 212 degrees Fahrenheit. This is obviously greater than that, so yeah, the water has boiled or is in the process of. Actually, it's past that. So anyhow, so multiply first, then add second. All right. Again, when you're converting, see how I have the formulas here? This formula, there's no parentheses. What's nice about this worksheet is temperature conversions is I believe all the formulas you need, and like this fraction decimal conversion, it's all right there for you. Follow the formulas. All right. Here there's parentheses when you're going from Fahrenheit to Celsius. Over here, when you're converting from Celsius to Fahrenheit, there are no parentheses. So do not put parentheses in this formula. I can't stress that enough. And the reason why I'm stressing that is because every year, I have some students who get a little crazy with parentheses when you don't need to. All right, so just please be aware of that. Now, there's 3 temperature scales we listed up here: Fahrenheit, Celsius, and again, some of you might have heard about Kelvin, some maybe not, I don't know. But Kelvin is a temperature scale where we account for, all temperature scales we're accounting for molecular motion, but the Kelvin temperature scales takes it all the way down to where you have 0 molecular motion, and they call that absolute zero. All right, absolute zero is the point at which all molecular motion stops. So, for example, if I'm teaching this lesson right now, and the temperature in this room suddenly plummets to absolute zero, then I would be frozen solid just doing this. Maybe I'm pointing at the board and looking at the screen like this. All right, can't do that very long without trying to, crack a smile, but that's just how it is. But that's anyway where I was paused there. The video didn't freeze or anything. I just tried to stay there for a few seconds anyway. That's demonstrating absolute zero. Now, was it really absolute zero? Of course not, because the blood's still flowing through the veins and arteries and all that. So it's not truly absolute zero, but and it's a theoretical temperature. Okay, it's never been. They've never achieved it in the lab, and the closest they've come to in nature is like they theorize that in the deepest, darkest parts of space, the temperature is still something like this. All right, just 0.0000001 Kelvin. All right, so that's extremely cold. All right, no doubt about it, the deepest, darkest parts of space. But it's not absolute zero. Okay, so it's basically a theoretical temperature. Now, to convert from Celsius to Kelvin and vice versa, okay, you have this formula, these 2 formulas rather. I'll be honest with you right now, the more common of the 2 formulas is this one. Okay, this is one we tend to use more than this. All right, but this one does, this one does exist, so there it is. Now, water boils at 100 degrees Celsius. What's that on the temperature scale, on the Kelvin temperature scale? What's 100 plus 273? Yep. Yes, you need to show the work. There's your answer, 373 Kelvin. You notice anything that's missing here? There's no degree symbol. standard convention is when you write temperatures in Kelvin, you do not include the degree symbol. It's just 373 K. Put a capital K, and that's it. All right, for converting from Kelvin to Celsius, you simply subtract the two numbers. By the way, with Celsius, the one thing I forgot to mention earlier, some students might have the misconception that there's no such thing as negative Celsius temperature. That is wrong. Okay, you can have negative Celsius temperatures. All right, FYI. Anytime the temperature drops below freezing, you think about it. Freezing, 32 degrees Fahrenheit. Well, that's 0 degrees Celsius. Okay, so if the temperature outside is like 21 degrees Fahrenheit, then it's below 0 on the Celsius scale. We don't call it below 0 because we use, of course, the Fahrenheit scale here in the United States. We know below 0 is -1 degree, -2 degrees, 3 degrees, whatever, below 0. All right, but any temperature from 31.9 degrees Fahrenheit and less than that is going to be a negative number on the Celsius scale. Now, what you can't have are negative Kelvin temperatures. Because absolute 0, as I demonstrated to you in the video a few moments ago, absolute 0 is when all molecular motion stops. Okay, so like I said, temperature drops to absolute 0, we're frozen solid, doing what I'm like this, or doing like this, whatever. Now, to convert from Kelvin to Celsius, it's just the opposite. You subtract 273. So it might be something like this. Let's say the Kelvin temperature is 271 degrees. All right. Now keep in mind, we are going from Kelvin to Celsius, so we can have negative numbers. 271 minus 273 is, of course, -2 degrees Celsius. Now, you can also, and I do have one problem on here where you need to do this, you can convert from Fahrenheit to Kelvin. Okay? All right, to convert from Fahrenheit to Kelvin, all right, shorthand, convert from Fahrenheit to Kelvin. What you need to do first step is convert the Fahrenheit temperature to Celsius using the appropriate formula. And then the second step is to convert from degrees Celsius to degrees Kelvin. All right, it's just a two-step problem instead of a one-step problem. Not a big deal. So to convert from Fahrenheit to Kelvin, start out with Fahrenheit, convert to Celsius first, then take the Celsius, convert it to Fahrenheit, to Kelvin. All right, convert to Kelvin. Sorry, my mistake. Now, there's one problem on the temperature conversions worksheet that I posted yesterday where you have to convert from Fahrenheit to Kelvin. Whatever you do, do not leave it blank, because you don't need to leave it blank. I just told you what to do. All right, it's just 2 steps here instead of 1. That's all. That's the only difference. So I want you to make sure you try it. If you miss it, that's okay. I'm going to give you the correct answer, but you got to try it first. Meet me halfway, please. All right. If you have any questions, let me know. I'm more than happy to give you a hand with this. And you got till, of course, Tuesday night at 11:59 to turn these in. Take care of business. This shouldn't take you that long because it's just some calculations in that. But I want you to make sure you get the assignments turned in on time, because some of you are hurting on your weekly attendance because you're not meeting the deadline. So make sure anytime between now and 11:59 Tuesday night, take care of this, get it turned in.